All right, today we're going to talk about woodland management, and I think this is a really important topic area, and it's also something that is well within my expertise here at the university. So, uh, have you ever thought about what a woodland actually is? Most people think of this incorrectly. So they're thinking about a woodland as just being the lot of woods behind the house or something like that, or maybe one of these forest patches on campus that are protected. But that's not actually what woodland means. So a woodland is basically a low density forest, and it's providing enough sunlight penetration to the understory so that we have uh, herbaceous plants and woody plants that are regenerating in the understory. Okay, that's very similar structurally to what we would think of as savanna. So if you think about like longleaf savanna, the key difference between a savanna and a woodland is a woodland can have vegetation in the understory. So we're basically, when I say understory, I mean vegetation below the shoulder height. That vegetation in a woodland can be dominated by woody species. So we're talking about plants like young trees that are regenerating or shrubs, those sorts of things. That's okay in a woodland. If it's dominated by herbaceous material and we're low tree density like this, that is then a savanna. Okay, so the savanna has a herbaceous ground layer in this understory, or it's dominated by that. So that's a key distinction. Functionally, they can be very similar. Most of the wildlife species that we have in the southeastern United States need a structure similar to what you're looking at right here. And it doesn't matter whether it's a woodland or a savanna. Uh, as long as we have this two-tiered forest system where we have a broken canopy, that's one tier in the overstory, and then the other tier is the understory. Notice we're basically absent of a midstory here, or in other words, things that are in a subdominant position that are above shoulder height, but not the first line of contact to the sunlight. So that would be things in the mid-story. It's pretty much absent here, and that's a very important structural component to our forests that is important to many of the wildlife species in the South, including virtually all of the upland species that are species of conservation concern or connected to this type of structure or grassland. So when we're thinking about managing forests for wildlife, this key component of that of our thought process is structure. So if you've already watched the other lecture where David talked about succession, you'll understand that changes in structure through time, through vegetative succession, can affect which species are associated with it. A diversity of structural characteristics within a forest. In other words, if you have several stands that are managed in different ways and you have different structures, that often provides the best opportunity to manage for a diverse set of wildlife species because they all have differences in the fine scale structural characteristics they need. If we're looking at it generally, it needs to be in this, woodland structure in general, but having some three-tiered forest systems or a developed mid-story can be beneficial for some of the species as well. So keep that in mind, or it could be just for some of the components of habitat. A key point of this is we typically think of managing for wildlife or managing for timber as being a trade-off, and they don't have to be. And we're going to talk about some of those practices. A lot of the things that we would do to try to maximize timber revenue can also have wildlife benefits. And it's really important for you to consider because in the southeastern U.S., most of the land is private. And most of those landowners, even if they are interested in managing wildlife, they are also, often interested in also gaining money from timber revenues. So that's a very common. It's very common for those two things, managing for wildlife and timber production, to be the top two objectives of landowners in the South. So very important to think about. there's some basic questions that we need to think about when we're managing wildlife. Again, we need to think about which wildlife we want, where do they fall in this successional gradient here, and then how does that relate to the timber management goals. So this is showing you succession. If we were managing forest for timber, the most valuable timber is over here on the saw log in general, and you know, where we're at in the successional thing obviously can have a big impact on which species are present and what habitat components we're providing at that stage. So they're an integral part of a forest management strategy to think about those two things, wildlife habitat and timber production in tandem, especially when they're both high on the list of objectives. So the most common method that you've probably seen for regenerating forest, okay, let me make a key distinction here. I'm gonna show you some regeneration methods, and I'm gonna show you some timber stand improvement practices. The key difference there is a regeneration method is designed to regenerate a new forest. So the objective is to replace the forest that you're cutting down with a new forest. A timber stand improvement is designed to enhance the quality of timber that is existing. Both of those practices we're thinking about from a forestry standpoint and have a big influence on the structural diversity in the plant community that affects wildlife habitat. So important things to think about. Clear cutting is really commonly used as a method of artificial regeneration in the South, and in particularly with loblolly plantations or slash pine plantations. That's really common. The key difference between artificial regeneration with clear cutting or natural regeneration is obviously that we're bringing tree seedlings in and planting them in rows in artificial regeneration. So we're bringing these trees that are going to grow in there from off site to plant them in the site after we clear cut. A clear cut is basically removing all of the trees in at least a half acre or larger area. Okay, we're going to talk about another practice that's kind of similar that's less than a half acre each cut. So keep that in mind. From a wildlife standpoint, though, the difference in artificial regeneration or natural regeneration for clear cutting is not actually in whether or not we bring the trees from off site that are going to be that we're going to regrow. It's actually has to do with site prep, and we do all kinds of things. What you're looking at right here, we have bedding that occurs really commonly, and it's basically dragging a plow through there to raise the beds, and then we plant the seedlings in the bed. We have all kinds of practices like this that we use. Herbicides are probably the major one that affect the plant community structure, but think about from a wildlife habitat standpoint, when this starts growing, the structure is right, and the plant community assemblage is what really is dictating which wildlife species can use it. And these practices right here affect very greatly which plants regenerate in that. So in natural regeneration, we might clear a cut and then just let whatever colonizes the site from the seed bank or from seeds, you know, blowing in or whatever. We just let that happen. But by design, if we bring trees in and plant them, we're trying to limit all of the natural plant community in that case. So that makes a big difference to the quality of habitat for wildlife. So there are several natural regeneration methods, and again, you could use clear cutting in this way, but there's also some variations on the clear cut and other strategies. So like the strip clear cut method, essentially this is greater than a half acre where we cut all the trees, and it may be in a long linear strip. And the idea is that if we have, you know, pine plantation on both sides of it that have mature trees producing seed, those seeds can more easily colonize or be blown in to colonize the clear cut, and we could regenerate forests, you know, new pine trees that way. A seed in place method is similar, where we would actually in many cases thin the trees, but the idea is that we could prep the seed bed by burning. We might do that under a forest canopy and just try to prepare the seed bed and then wait for a big cone year where we have a lot of seed production to be cast on that newly burned area, and then go in and remove the trees. That one's not used as commonly as the clear cut methods, but it can be used effectively to regenerate pine in particular. Key benefit again is that these natural regeneration techniques allow wildlife habitat to recover really quickly because we don't have that intense site prep. But it has disadvantages in that we don't have as much control over what type of forest colonizes the site, and how that stand succeeds and what the value of that stand would be at the end of the rotation when we harvest again. So we have a couple of other methods that are pretty similar where we might reduce the tree density substantially. So a shelter wood cut, that's really commonly used when in oak stands in the South. The seed tree regeneration method is more commonly used when we're trying to regenerate pine. So the idea is that we remove at least roughly 50% of the canopy. In the seed tree cuts, we might remove 80 or 90% of the canopy even. And the idea is to leave trees that, in the shelterwood case, is literally providing shelter to advance regeneration in the understory. So when we're thinking about oaks with that shelter wood, the idea is that we gain a little bit of control over the natural regeneration because we leave some overstory trees, not because they're going to produce a lot of acorns, but they create a variable lighting condition in the understory and a suitable microclimate for acorns that are on the ground to germinate and regenerate. And then the idea with that method is when we remove initially 50% of the canopy, we wait until we have a well-established advanced regeneration. That just means a lot of oak seedlings or saplings in the understory and midstory. And once those are established, we would then go in 8 or 10 years later and remove the overstory shelter trees. Okay, so the shelter trees are not to increase mass production, they're to provide the conditions for acorns on the ground to germinate and flourish. The seed tree method is different than that in that we're leaving trees, pine trees generally, so that they can produce seed in the stand to regenerate. So we're actually leaving targeted trees. Normally we would leave ones that have really good form, and also if we know the seed production of potential of this tree, we'd leave ones that have been producing a lot, with the idea that we can leave those trees to establish that advanced regeneration of pine seedlings, and then later down the road, when that's established, we'll come in and remove those other standing trees that we retained. So major advantages over other regeneration methods like clear cutting, because that advanced regeneration gives us a lot of control over what kinds of plants colonize that area, so that we know, we're going to grow a new oak or a new pine forest as is desirable. Remember, all these regeneration techniques are specifically trying to regenerate forests. So many of you have probably seen a stand like this. A lot of our national parks look like this, at least the ones I've been in, especially in the Appalachians. You'll see these upland hardwood forests. This is actually an exclusion cage right here that's excluding herbivores. You can see there's nothing in the understory for the most part in terms of plant community structure. We have a really well-developed overstory, well-developed midstory, very little sunlight's getting to the ground, and that is limiting plant community structure in the understory, not herbivory, which is herbivores often get the blame. That is not why we don't have that understory strata. Most of the wildlife species in the South, though, don't do very well in this condition. Think about deer, for instance. You know, most people think, oh, there's plenty of acorns there's oaks dominating these stands all through this. They probably do awesome. Well, deer, about 80% of their diet over the course of the year is not acorns. So they need to eat green plants, and you can see there's not much to eat in this understory, right? So a lot of our wildlife species, other than deer, also need that structure for foraging or nesting or other habitat components. So if we go in with some of these cuts and remove part of the canopy, so this would be, if you look out through here, this was about 50% of the forest being removed, and we add fire in, now we're starting to develop that understory structure that's desirable. Here's another picture of that. You can see, based on this guy here, the vegetation's about knee tall. It's probably about waist high or a little taller up here. And the idea is that we're getting enough sunlight into the ground that the plant community can respond to fire. And this two-tiered forest structure that you're seeing with the overstory and the understory is essential for those wildlife species to be able to respond. So all of those methods that I've mentioned so far were even-aged regeneration methods. And you think about, okay, we have that shelter wood technique, for instance. We have the overstory trees. We remove some of those. We establish that advanced regeneration. Now we have two age classes, right? We have the overstory and the understory that have our targeted tree in it. Same thing with clear cut. You only have one generally in that one, right? You go in and clear cut, and then you plant or you allow pines to establish back in that. In each case, you only have one age class of our desirable tree. In uneven age, we have three or more. And there are a couple of variations on this, but essentially, if you look at the size of the trees that occur in an acre, the number of seedling sized or really small trees is really high, and the number of really big trees, or those saw log sized trees that you can't reach around, there's very few of those. And there's a lot of advantages to this. Excuse me, I got tripped up. There are a lot of advantages of this to wildlife because it creates a lot of heterogeneity in forest structure. However, we don't have very many trees that are targeted from a timber production standpoint in the South that do well in this. Longleaf has had, there's been some success using this, but other forests or species that we would want to regenerate in the South don't do very well because the species that do really well in this context are generally shade tolerant species. So in other words, they can withstand trees overtopping them and catching the sunlight while they're regenerating. We just don't have many like that. There are a lot in the Northeast and upper Midwest that do really well in this type of system, but not so much here. In irregular even aged, you just have several, just an irregular shape to this pattern, but the same general idea that we have a whole bunch of really young trees and very few really big ones. So here's kind of giving you an idea of some of these. You remember I talked about the clear cut was greater than a half acre. Well, a group selection cut is an uneven age stand management technique where all these group selections that you're seeing right here are less than a half acre. We're basically punching holes in the canopy, and that can create a lot of structural diversity in these stands. Here's an uneven aged pine stand, just kind of giving you an idea of showing you several different size classes of the pines in that stand. A timber stand improvement, again, this is not designed to regenerate new forest, okay? That is not the objective. Our objective of removing trees in this case is to improve the ones that we didn't cut down, all right? So that being said, there's the most common thing that we would do would be to thin, okay? So you may have seen this in pine plantations where we may have a fifth row thin or a third row thin or something like that, where we're going in and just removing one of the rows of trees before they get to that saw log stage. So you don't get as much money off the timber product, but it helps the remaining trees get to that higher size class faster by reducing competition, but also can give you some control over the form of the trees that reach that cut. From a wildlife standpoint, that's benefit in many ways because it's increasing sunlight that gets to the forest floor. That's the critical thing that we need to consider. A variation on this, I studied it actually during my master's work at the University of Tennessee. It's called a wildlife retention cut. And this was actually designed to be very similar to the shelterwood cut, where we're removing about half of the trees, but instead of trying to maximize space and have a uniform distribution of the overstory trees and only retaining the desirable tree to regenerate a forest, the wildlife retention cut, we take a focus on wildlife. So we're removing half of the trees, but the ones that we removed in comparison to the shelter wood might be very different. Generally, the trees that we leave following a retention cut would be the ones that produce mast because they're high quality foods, and that could be acorns or black gum, things like that are producing soft mass, persimmon. We're retaining those trees, or trees that have a high uh, propensity to develop cavities. So things like that provide wildlife habitat. Another key difference in the wildlife retention cut is we don't actually go in and harvest the timber. In most cases, we would actually just go in and girdle and or hack and squirt trees to kill them and leave them standing. And that creates a lot of snags in those areas that are also a really beneficial component of habitat for a lot of our species that need snags. So it's just a standing dead tree. So in general, when we're targeting wildlife, we want to remove at least 50 or 60% of the canopy, and we want that low basal area so that we get plenty of sunlight to the ground. Here's kind of showing you a wildlife retention cut in an oak stand where we've retained a few oaks in the stands. There's a soft mass producing tree, and then you're seeing how much sunlight is getting to the ground and how quickly. This is only a couple of years after cutting, and a really poor site. There's also already really well developed understory in that. Again, this is not designed to regenerate new forest. We are strictly trying to increase habitat quality for wildlife through the cut. The basic needs to do that are light and disturbance. So once we remove some of the canopy, you can see some of the snag standing in this wildlife retention cut. We're getting that sunlight through. This stand or this understory right here will quickly get up into the midstory, and we lose wildlife habitat quality immediately once it does that for a majority of the species in the south. So fire comes in there, where we might use that in tandem with this canopy reduction to essentially extend how long the understory remains in the understory. So every time we burn through here, we top kill or outright kill all these plants and continuously keep lowering the structure back down into the understory. This retains the plants community in reach of herbivores, also maintains structure for nesting or foraging for insectivorous birds or whatever. This developed understory like this is what we're trying to maintain. So we might burn every 2 or 3 or 4 or 5 years, depending on where it is. Generally, we're not going much longer than that in the south, although we might in places where the growing season is shorter, up in the northern parts of the U.S. But in general, we're trying to burn frequently enough that as soon as plants start getting up into the mid-story, we're then coming in with fire and knocking it down again. So think about this, when the plants are taller than your head, it's time to burn again. Another really common misconception in the South that you might have to deal with is the idea that we can't burn in upland hardwood stands, and that's just simply not true. That idea comes from the this fear that we're going to damage all of our overstory oaks that are super valuable. And when we're using fire in these systems, we're trying to use a really low intensity fire like this that's a really low flame height. And basically what happens is they burn right around that tree. This tree right here was burned around many times over again, and it was not harmed by this low intensity fire. I mean, we can literally walk through that fire line right there, right? So uh, many of these stands that I was studying during my master's, we had repeatedly burned, and then when we came back in and harvested the overstory trees, there was no depreciation in value of those trees. Now, that's not to say that we can't harm trees with burning, but we're generally doing it in a way, applying the fire in a way that we're not going to harm the trees. That's the intent. For some of you, or let's back up. So some of the ways that you might harm trees are, one, using firing techniques that create a really intense fire. Another really common way is if you have thinned or you're in one of those wildlife retention cuts and you have downed wood like this, if that catches on fire near the base of this tree, that will harm the tree. You can see the cat face developing on the side of this tree. That one has been damaged because it has this downed woody debris right next to it. For some of you that are in law enforcement, you're probably going to have to deal with arson a lot, especially in the South. That seems to be the thing to do in some places when people get upset. You'll see arson. So I thought it was really cool that one of the things I went out with the law enforcement officer actually in Florida one time, and he was showing me the things that they were looking for to try to figure out who set a fire and where it started and what caused it, all that sort of stuff. So you can see this little band behind the tree. Essentially, the we know that the fire was started over on this side and progressed this way through the stand because it had to wrap around that tree, and it took a little while for it to converge. Another really cool thing about this is, people commonly come to me and say, well, what about burning up birds' nests that are nesting on the ground? And I was actually in Tennessee when we were doing this burning following turkeys. The other graduate student was working on turkeys, and we commonly would find nests in this little fire shadow. So the bird would actually nest on the backside, and we'd have fire go through the stand and not impact the nest, which is pretty cool. Saw a bunch of turkeys fled from it. There's a lot of research coming from University of Georgia that's suggesting very similar things. These species nest on the ground in the South and have done so ever since they were a species, and they choose to do it right in the peak of fire season in a place that burns on average in Florida every 2 or 3 years. So if that was a really big problem for those species, they probably wouldn't nest on the ground or wouldn't nest at a time of the year when it's flammable. So natural selection has still favored that behavior. And if you think about all the benefits to habitat that that's having, it probably outweighs any negative influence of fire on that nest. So that's something to think about. uh, so the timing of fire can also influence things. I'll talk about this a lot in the habitat management class. If you are interested in taking that class, we'll talk about timing. But most of the characteristics that we're trying to manage for wildlife when we're including fire in these woodlands are dependent on the frequency of fire. So how often do you enter the stand again with fire? But timing can be important for some reasons. So I just wanted to show you some data from these stands. So if you look at how much fruit is being produced in these stands, notice that control just means an unmanipulated forest that's closed canopy, hardwood. Not much fruit is being produced. If you insert fire into that system, light is still the limiting factor. That's important for you to remember. Light is limiting the wildlife community, and that is because it's limiting the plant community. Light is limiting first in this system. As soon as you reduce the canopy and allow light in, you improve most habitat components, including fruit production. If you put both fire, if you couple canopy reduction with fire, then that augments that process. So you get even more out of it, right? So fire alone doesn't work in these systems because there's not enough sunlight for the plant community to respond to the fire. Here's showing you another thing. Just if we think about, okay, 0 means the same year fire was implemented, 1 year means the next growing season, 2+ means after that. The colors here are talking about what month the fruit is being produced in. So you can see when you burn, fruit isn't available till a couple of years after fire. And that could be pretty important because depending on how frequently you burn that stand, you could have a whole bunch of fruit, or if you're burning more frequently, as we often do in Florida, you may lose fruit. There's been a lot of discussion over whether or not burning frequently enough could reduce fuels enough so that you have this mosaic and fire spread. So I did an experiment related to this during my postdoc work where we burned on 1 year, 2 year, or 3 year intervals. And you can see that same process happened, that when you burn on a less than 3 year interval, for the most part, fruit is eliminated in the understory in that system, which could be problematic if you're doing it at a large scale. Now, think about it from this point of view. There's always winners and losers. The 2 year or 1 year interval benefits a lot of plants and a lot of wildlife species that don't need fruit. But if you did only that, things that need fruit might suffer as well. So that's why it's important for us to mix things up and have variable applications of practices like fire. So just to give you more data, showing you the same thing, this is ground cover for nesting for turkeys or things that nest at low in the understory, not necessarily on the ground. You can see that that improves, especially when you have canopy reduction with fire. Here's just showing you forage, and this is shelter wood with fire, so a canopy reduction with fire, and then that retention cut, that wildlife retention cut, showing you that. This stands for herbaceous, basically, or herbaceous. This does not stand for herbaceous. This stands for herbicide. So it's basically showing that if we go in with a site prep to try to kill the unwanted plant species, we reduce the amount of forage available for deer. But you can see that same process, canopy reduction with fire, has a really big positive impact on this metric. So I'm going to stop there for this one, and I'm going to have a short clip on managing for acorn production that I'll also put on today. But I appreciate your time, and I look forward to discussing this week with you.